Now, in many cases, whenever you are given a geometric progression which is finite, what I mean by finite is that the first terms and the various intermediary terms and the last term is also given. So this is the last term of a geometric progression. And you are told to find out the sum of a geometric progression, okay, when the last term is given. So we know that, the sum of a geometric progression is equal to a times 1 minus r to the power n and then 1 minus r, right? This we have derived through a formula or a theorem which we have discussed in the previous videos. In case you haven't had a chance to go through it, you can please go through it. Also, what we know is that the last term or L of a geometric progression can be written as a r to the power n minus 1, right? So is there a way to simplify this formula if you know the value of the last term? Just in this case, you know that the last term is 12,288. Can we try and convert this formula into something which is a little bit easier than this calculation? Okay, so let's say, for example, a doesn't seem to be any kind of an issue, right? Now, if we multiply a with 1, what do we get? We get a in the numerator. Then a when multiplied by r to the power n will give you a to the power a into r to the power n divided by 1 minus r, right? Now the last term is equal to a times r to the power n minus 1, right? Can we write a r to the power n, which is the second term which we have in this formula, as equal to a into r to the power n minus 1 into r? If you see, if you multiply these two terms together, this is nothing different than this. But what I have done by doing this is, I've got this value which is nothing but the last term, or I can just simply write this as L times R, right? So we can write this as A, okay, minus L times R divided by 1 minus R. Right? So that is the other formula that you can use for calculating the sum of a geometric progression, right? But please note that even in this case, if r is equal to 1, then basically my denominator will become 0. Hence, this sum formula or the theorem is not applicable if r is equal to 1. Again, if r is equal to 1, we can just simply apply the same thing which we learned previously in the other videos. Now, if we apply this particular formula to the present case, what is the value of a? A is nothing but the first term, which is 3, minus L. L is what? 12,288 into common ratio. What is R? Okay, let me find the value of R is equal to 12 upon 3. This divided by this. 4 into 4 divided by 1 minus 4. So basically now if I look, 1 minus 4 gives me minus 3, and here I get 3 minus 12,288 into 4. 12,288 into 4 gives you 49,152. This is with a minus sign, right? Plus 3 is equal to minus 49149 divided by minus 3. This was 49152, right? And if I divide this by 3, what do I get? I get 16,383. 16,383. This minus and minus will make it positive, right? So when I know the last term of a geometric progression, instead of applying this particular formula, I can also calculate it by using this particular derivation that I got from the main formula, right? The problem in applying in this particular formula in this case is that we do not know what is the value of n, right? So while, if you start multiplying these numbers one by one and putting them together, you might reach this last term as well and count the number of terms. But that's a rude and a crude and a raw way of calculating it. So instead of doing that, we just apply this particular formula.